Hi there, I've just got a video camera, ooh. And to practice using it, I thought I'd do a little multimeter teardown. So what I've got here is a $15 multimeter that I got from Sparkfun. Can a $15 multimeter be any good? We'll take it apart, have a look inside, find out. I've also got this. I found it in a shop the other day. €4.50 for a multimeter. Can a $5 multimeter be any good? We'll find out. And I've also got, the day after I found this, the very next day I was in a different shop. I found one for €3.50, battery included. Can a $4 multimeter with battery be any good? We'll take these two apart as well, find out. So let's start with the Sparkfun Multimeter. And yes, this is the famous yellow multimeter that was banned by the US government because it was too similar to one of these. They're both yellow, apparently. So a whole batch of these was confiscated and destroyed just because of the colour. Thanks, Fluke. World's a much safer place. Okay, let's start the test with the Sparkfun Multimeter. It's a very basic meter, just ohms, volts and amps. Manual ranging, continuity buzzer, and that's it. No other features at all. What it does have is a nice big clear display. It does fit nicely in the hand. This is just the perfect size and shape for a multimeter. Has like that clickiness in the dial. Overall, very well designed, feels well put together. I like it. Now, this meter is usually around the bench somewhere, and often it's the meter I pick up and use. Why is that? It's just a likeable multimeter. And even though this is a very basic multimeter, it's quite often the meter I'll use when I just want to take a quick reading. And the reason is it doesn't annoy me. It just gets in there, takes the reading, job done. I'll give you an example of a meter that isn't like that. This one here. Every time you turn it on, is it going to do anything? Signs of life, hang on. Oh, ready to use. And the time it takes this meter to turn on, I can turn this one on, get in there with the probes, take my reading, I'm already done. Just in the time it takes this one to start up. This one's annoying, this one isn't, so this is the meter that gets used. Simple as that. And I think physical size is also a factor. This is quite a small multimeter, as you can see. And you know how desktops get, you've got your Arduino, some breadboard stuff, cup of tea, roll of solder, notepad, your calculator, might have your oscilloscope on the bench, get your multimeter out, fits on the table. If your multimeter is the size of an Imperial cruiser, where the hell am I going to put this? I've got to rearrange the side of the table just to get the multimeter on. I don't think so. Give me the small meter. That's not a moon, it's a multimeter. Can't be, it's too big. Okay, so some basic functionality tests. Turn it on, check out the display. As we said before, nice big digits, easy to read, no problem there. Can we use it one-handed on the table? One-handed table test. Fail. It's quite spinny. If you look at the back of it, you'll see that it rests on there's 4 little dimples there, and there's kind of a raised up line in the centre, and it pretty much spins on that line, as you can see. Whee! No chance at all using it one-handed. Same thing on the little stand, quite a nice little stand, but not a chance at turning that. Well, I cheated, I used my finger. I suppose, yeah, you could do it like that, but nah. Okay, while we're on the stand, yep, flips out, holds it a little bit wobbly, sort of does the job. And just to compare with the Flukes have a big rubber strip on the back like this, and then in between that and the sheer weight of this thing, You can turn that all day long, one-handed, not a problem. Same thing for the stand. I mean, check this thing out, look at it. That's not a stand, this is a stand. Stand it up there, turn it around on stand, one-handed, not a problem. Continuity tester test, which sounds wrong. It is fully latching, and you can definitely make it miss some. Medium speed, 5 out of 10. And let's do some electrical measurement tests. I've got a little board here with some precision references on it. We've got ohms, volts and amps, 2 of each. And the ohms, we've got some precision resistors on there, 0.01% tolerance. For the voltage, we've got some precision voltage references, 0.05% tolerance. And for the amps, we've got 2 precision current sources, 0.5%. Not quite as much, but still pretty good. And let's start with the ohms. This should be 10k ohms. Get it in there. 999, off by 1 digit, pretty good. And of course this is a manual ranging multimeter, so I've got to click it down a notch and measure the 1k resistor. And here 1001, yeah, pretty good. Off by 1 digit, nothing to complain about. 5 volt range, so that would be over here, 20 volts. I measure that. 4 probes the wrong way around. Yeah, no big deal, but let's do it right. 4.99, again off by 1 digit, nothing to worry about. And the 2.048 volts. Now this one's a little bit tricky when you're on a 2000 count multimeter like this one, because it's slightly over the 2 range, and that's a little trap I built in. So we have to stay on the 20 volt range to measure this one. But still, 2.04 should be 2.048. Technically, I suppose that should be 2.05. So we can say it's off by 1 digit, but you know, 2.04, not a problem. And if we go to the amps range, this should say 10 milliamps. 9.96. 4 digits off. But amps are quite hard to measure, so we'll forgive it. I go down to microamp range. This should say 100 microamps. What did that say? 99.9. 100 microamps. Bang on. Okay, enough chit chat. Time to get this thing opened up, see what's inside. So we've got 1 screw here holding on the battery cover. Not captive, obviously. And we do have a metal insert. Not bad. Got to take the battery out. I think this is actually the original battery that came with the meter. It's lasted a couple of years now, so power consumption, good. And then there's 2 more screws, self tappers. And if I remember how to do this, you've got to lift that up there, slide that forward, and then thread the battery snap down through that hole there. And if we get it all right, we're in. So what are we expecting to see? We want 2 fuses on the inputs, 10 amp range, 200 milliamp range, and Cat3 input protection, 600 volts. So take a look. And check it out. Yeah, it's got 2 fuses, obviously. Only glass fuses, not the HRC type, but yeah, 15mm. What do you expect? And 2 PTCs on the input protection here, going up there. Resistor ladder, mouth-mounted resistors, very nice. And up here there should be a MOV, but I can't see one. Yeah, no MOV. So not perfect, but what do we reckon? Cat 3 rating? Without going into detail, I mean, certainly the basics of proper input protection, which is what we want. Cat 3 rating? Yeah, maybe. And the next thing to look at after the input protection is these metal binding posts where the leads connect to the meter. And these need to be as solid as possible and give years and years of use. Now these posts are fixed to the PCB, which isn't ideal, but you know, they seem to be soldered all the way around, and it looks like a proper soldering process, not just some kid with a soldering iron. Put them there. So, pretty strong. And notice that they are proper metal tubes. They're not just a rolled up piece of metal with a split down one side. You tend to get on cheap multimeters. Points for that. And if you think about it, these probes come with a plastic shroud around them, which goes into this groove here. So when you're pulling on these wires, what actually takes the strain is this plastic shroud and the front panel of the meter. You're not actually pulling directly on these posts. So, you know, got to assume they've done their homework, and these are good enough. As I said, not ideal that they're on the PCB, but I don't see a massive problem with that. And that goes for the rest of the board as well. Not just these posts, but you know, the fuse holders, these mouth components, and in general, standard of soldering, general construction, pretty good. I've seen worse soldering than this in $100 products. And one more little thing I've just noticed about this PCB is that every single component is marked not just with the identifier, but with its value. Here, RS3 90K. It's a 90K resistor. And you go over here, for example, this one's 100K. This capacitor 2104. All the values are marked. And it's just little details like this that give you confidence in a product. You know, it's nice, nicely designed, nicely presented. You know, you're not even supposed to be looking inside this thing, but they've made a bit of an effort to make it look pretty. If you do, I like it. So there you have it, Sparkfun Multimeter. Well designed, well made, nice to use, and $15. Bargain. And now it's time for cheapo multimeters. Look at this, €3.50, transistor tester and battery included. So the first job is to get them out of this awful packaging. I really hate this stuff. Invented that. And as you can see, each meter comes with its own set of probes, obviously, and it also has a small operator's manual. And check this out. It's actually got full specifications and accuracy for each of the ranges. DC voltage, AC voltage, DC current, overload protection, full specifications. Interesting. We'll certainly check out those figures later in the test. First impressions. Well, this one's a lot nicer plastic, nicer colour, nicer moulding. This one looks really, really nasty. Ew. Check this out here, look, case doesn't even meet there, doesn't join. See the gap up that end and then the gap down this end? So, no, not going together. It's just a crappy moulding. This is the worst one of the worst pieces of plastic I've seen in a long time. It's just nasty there. And there's little bits here. Look, check this out. Little bits of excess plastic there from the moulding. And here on the screen as well, another piece. And it just looks horrible. This one's much nicer. Plastic moulding, much nicer. And looks. See that there? There's like some little. Is it going to come out on the camera? Little kind of grey dots. Looks like dirt, but it's actually inside the plastic. This kind of recycled plastic or something. Yeah, I noticed here. Yes, I did cut my finger opening those blister packs. But yeah, looks like dirt, but it's actually in the plastic. This is really, really nasty stuff. And can I get that open? Yes, as claimed on the packet, this one comes with a battery. And this one, I'm guessing by the weight of it, doesn't. I need to find a battery, put it in. Okay, so I've got a battery in this one as well. Didn't want to open it up just yet on camera, but you know, it's now fully working. Battery in it, and this one also works. Good sign. With a Thought brand battery. Okay, let's do some testing. So let's start on the ohms range. So this should be 10k resistance, and it is 10.04, 10.03. So yes, that's less than 0.5%. And check out the 1k range. So far it's within spec. 1k. 1.000. Oh no. Again, it's within spec, but it's bang on. And we switch to DC voltage. This isn't supposed to happen, by the way. DC voltage. Okay, 5 volts. Straight face. 5 volt range. 4.96. Okay, not so good. And yeah, I suppose you have to leave it there for the 2.048 volt range because of the little trap I mentioned earlier. So 2.03 should be 2.05, so it's within, yeah, less than, well, about 0.5%. And we flip it round and check out the amps range. Now both of these meters do have a microamps range, which is good, and I'm going to check that out. So first we're on the 10 milliamp range. Should say 10 milliamps. Are we getting in contact? What's going on there? 9.99, 10. 10 milliamps. Bang on. And if we drop down to the microamp range, 100 microamps. 100 microamps, ladies and gentlemen. And let's check out the €4.50 meter. Now, according to the bits of paper that came with it, this one should be slightly worse, according to the specs. Let's find out. And so we want to start on the 10k range, 10k ohms. So 10k ohms. 10k, there it is. You saw it, 9.99. 10k. And the 1k ohms range. 1.0010. 1.000. I mean, that's within
you know, this blob of solder here. Let me touch it in a different place. 1.00, yeah, 1.001. And moving on to the 5 volts range. Trying to ignore the results. 4.995.00 volts. Bang on. And the 2.048 volts range. So I should say 2.05. Everything goes to plan. 2.04 oscillating. Touch it again. Oscillating 2.04, 2.05. So 2.048. Bang on. So let's check out the milliamp range. It should be 10 milliamps. There you go, 10. Oh, 10.55. 5.5% out. What did it say in the paper? According to this, it should be within 1.5% of the reading. 5% out. What does it say? 10.53. Let's just check the reading using this one. Have a quick. Just confirm the reading. So this was 10 milliamps. Yep, 10. So this meter, not so good on the milliamp range. Let's check out the microamp range. Bang on, 100 microamps. Wow. So the milliamp range, something weird going on there. Apart from the obvious cheapness of a meter, of course. It could be that. And now the moment you've all been waiting for. Time to take them apart. Ooh, what horrors lurk inside. Let's find out. And this one has the battery cover, and you'll note they didn't bother to put a screw in there to hold it on. It's got the hole, but they didn't put a screw in. That must have saved them like 1/100 of a cent or so. And this cover just does not come off. And under the cover, there's 2 screws here, which hold the back on. Somewhere safe, and the back just pops off like that. I'm not going to show you what's inside just yet. Keep the suspense going a bit longer. This one, no battery compartment, just 2 screws directly in the back. Get the back off. Come on, out. And there we have it. And time for the big reveal. Ta-da! Ta-da! And you'll notice that they're just as different on the inside as they are on the outside. This one, for example, has a little space where the battery goes, like that, 2 contacts at the end, a little plastic wall to hold the battery. You put the battery in, like that. Nice, I like it, good design. Hate these battery snaps. This one has the battery snap, but when I was putting the battery in, it wasn't at all obvious how the battery should go. There's no markings, there's no space, just a space where it goes. Does it go like this? Didn't seem to. No, does it go like this? Well, I don't know. Maybe, but if you look closer, there's like a sharp piece of metal here for the binding post. And it's cutting into the plastic of the battery snap. Is that going to cut through, cause a short circuit, blow everything up? Who knows? Terrible design. Ah. And let's take a look at the horror stories inside. And if you remember the things we mentioned before with the Sparkfun meter, we wanted to see some input protection, and there's none whatsoever in these meters. And there's a space here. It looks like there should be a fuse there, maybe, but it's just bridged in the middle at the moment. And same on this one here. There's a space for a fuse, but it's not filled in. And apart from that, there's just nothing. No protection at all. If you go sticking this in a main socket, I mean, who knows what could happen? It could catch fire, might fail, it might blow up, it might burn the house down. Who can tell? Stay away. I mean, it doesn't claim any cat rating on the front, so at least they're not lying about it. But you know, people could buy this, stick it in a main socket, and yeah, you don't know. Anything could happen. And the other thing we mentioned in the review of the Sparkfun meter was the binding posts. And these are complete garbage. Remember I said something about rolled up pieces of metal that will gradually unroll, open up over time. This has got them. 1, 2, 3, and look at that. It's just like a pressed piece of metal jumping across to the PCB from the input. Look at that, it's not even fixed in place. Ew. And this one, slightly different. It actually has a separate sort of daughter board area with the connectors on it. And same rolled up pieces of metal, but they're actually soldered on to the PCB with a piece of wire going across there, the bad piece of wire. And that's your common wire. And the other two wires, those like, just get a good close up. And what the hell is that? It looks like a leg they snipped off a resistor or something, and they've used it to bridge across from this board to the main PCB. And it's not even trimmed to the right length. What? And there's another one here. I can move that out of the way. It's just, I mean, what is that? What is the crappiest piece of wire I've ever seen? Just jumping across there. Unless this is actually fuse wire. It did say in the manual this was fully fused. Do you think that could be fuse wire, or do you think it's just a leg off an old resistor? Your call. And yes, while I was messing around with the battery just then, this wire did come off the PCB. Crappy dry soldering job. Let's see if we can get it soldered back on there. So I can get the right angle, of course. So how difficult is it to put some strain relief on the battery wires? Well, let's see what they did in the Sparkfun meter. In this meter, the wires come down from the battery, they go through a hole in the PCB, and they loop back underneath like this. I don't know if I can get that on camera. See that there? Come down, loop back under the PCB, and they get soldered to the PCB here. So when you pull on the wires, all the strain goes to where the hole is in the PCB. None of the strain goes to the solder joints where the wires are joined to the board. So it's easy, it's free to do. There's no excuse. Okay, how should we call this one? Well, if I had to pick one of these meters, I would go for this one here. And the reason is, they spent no money at all on the plastics, they spent all the money on the inside. And the designer has actually done quite a good job. He's put the input connectors on his little board over here, he's put in a proper little battery area and battery connectors at the end, so you can put the battery in and out without stressing these wires. You know, it's not the designer's fault that they didn't solder this connector all the way around. Excuse fingers. This should really be soldered all the way around the outside to make it stronger, hold it in place. Wasn't the designer's fault that they bridged this with a horrible piece of wire. That's down to manufacturing. But just purely from a design point of view, I'd go with this one. And this one, they've just tried to shave every single penny from the design. Look at these. I mean, these input connectors say everything you need to know about this meter. And the battery. Oh, look, the wires come off again. Like I said, the battery snaps, the whole design of that. So it's just. And one other thing I just noticed, this thing here, the current shunt, that can actually get quite hot. And look at that, these wires are touching the shunt. They can melt through, short out, you know, another major design flaw on this one. Current shunt is over here, out of the way it should be. So, purely from a design point of view, not manufacturing or anything like that, this one's a better meter. But in reality, of course, you wouldn't choose either of these meters. And the reason is, there's no input protection. No fuses, no PTCs, no MOVs, none of that stuff. And all those things aren't there just for your own personal safety, or to stop you burning the house down when you connect it up to 750 volts AC. Yeah, right. It's there to protect the meter when you goof up. You know, we've all done it. You put this in the wrong position. So you've got it on milliamp range, you go to measure a voltage, and bang! On this meter, you've just blown the fuse. Not a problem, you just get another fuse, 20 cents, put it in there, good as new. On this meter, you've probably just blown one of the resistors off the board. Something like that, you just lost your milliamp range, or maybe even lost the whole meter. So, you know, within the first month, you're going to mess up, you're going to take a measurement with this in the wrong position, bang, no more meter. Just not worth it. So, should you buy one of these meters? Of course you shouldn't. You'd have to be an idiot to buy one of these. Because for $10 more, you can get this. $10. Any questions? No. Buy this one. These two. Thumbs down. Both of them. So, Sparkfun Multimeter. It's well designed, nice to use, and we've taken it apart, looked inside. Build quality is excellent. Better than many multimeters which cost a lot more than this. I mean, I've seen, you know, 50, maybe even $100 meters which are built worse than this. So really, for $15, gotta give it one of these. In fact, I'm gonna give it 2 of these. It's that good. So there you have it, my first YouTube video. And if you've made it this far, well, thanks for watching. It's time for ginger biscuit, fresh cup of tea, and get this thing edited, uploaded to YouTube. See you next time.